Hello, in this video we will start our discussion about finite state machines. So as usual, let's start with the definition here. So a finite state machine is composed of a finite set S, a finite set I, a finite set O, a function G, a function F, a function G, and a starting symbol S0. Okay, S is a finite set of states. That's why the word state machines. And input alphabet is a finite set I. Output alphabet is a finite set O, and the function f is a mapping from an input to a state, and a function g is a mapping from a state and input to an output. Okay, and starting symbol S0 actually belongs to S. Okay, now representations of, so this definition is useful when we are actually solving the problem. But if we just look at the definition, it's hard to see what it actually means. So let's see the representation. So a state table is, remember, this is a finite set, right? This is a finite set, this is a finite set, this is a finite set. So this means we can write our function in a form of a table in which we can list all the inputs, combinations, and we can write the corresponding output for all those inputs. Okay, the same as we did for our Boolean functions. So typically you will see that the inputs will be of binary form, and output will also be of binary form. So then our typical state table will look like this, but we will come to this example later. So writing all combinations for S and I and listing the corresponding outputs for, so this is outputs for F and G for each combination. Okay, so the same as we did for our Boolean functions. And then there is another representation of state diagram, which is actually a directed graph. A directed graph is what? Vertices and edges are directed from in the form of an arrow from the starting node or starting vertex to the ending vertex or final vertex. So directed graph with vertices corresponding to states, in that our vertices are corresponding to states and they are represented by circles. So earlier we said that this is the normal form of a directed graph, but in this case we will write it like this, and we'll write the state number inside this circle, and we'll see when we'll do the examples. Edges are directed from an initial state to the next state. So edges represent which function? Edges represent this function. So if initial state is S0 and my f says that the final state based on the input is S1, then we have an arrow from S0 to S1. And edges are also labeled showing the corresponding input and output, so that we know that this input combination leads to this state and this output. Okay, so we'll come to this later. So let's go here and try to find the state diagram representation. So let's do this part first. Okay, state diagram representation of this guy. So our starting symbol is, S0. So this information is not written here, but we always assume this. So starting symbol. Okay, so this means that we start with our S0 as the. Now if we are at S0 and we get an input of 0, we are still at S0, right? So this means I will make, so input is 0. Okay, and output will put it later. If I am at S0 and my input is 1, I get to S4. So this is my S4. So this is my input of 1. Okay. If I'm at S1, yes, let's say S4 now. So if I'm at S4, if my input is 0, I get to S1. So S1 here, this is input 0. And if my input is 1, then I go back to S0. Okay. Now for S1, if my input is 0, I go to S0. And if my input is 1, I go to S3. Okay, and for S3, if my input is 0, then I go to S1, and I'm input is 1, then I go to S1. So 0 here and 1 here. And for S2, if I have a 0 in, so S2 is somewhere here. If I have a 0 input, I go here. And if I have a 1 input, I go here. Okay, now let's do the output here. So the first one was, if I have a S0 and my input is 0, my output is 1. So my output is 1. And my output is 1 for this one as well. So if for S1, my output is 0 and 1. So for S1, S1 is here. So for 0, I have an output of 0. And for 1, I have an output of 1. Okay. For S2, I have 0 in both cases. So S2, 0, S2, 0. For S3, I have 1 in both cases. So S3 is 1 here and 1 here. For S4, I have 1 and 0. So S4, if I have 0 here and 1 here. Okay. So this is my state diagram representation of this table. So it's this is the state diagram representation of this table. Okay. Now let's do some more things. Now we want to find an output string from a given input string. So now we are given, for example, we are given an input string of symbols x0 up to xn. Okay. Now given the starting state s, we can find the first output. So we have x0, the first input, and we have the first state, which is s0. So we can find the first output y0, which is equal to, remember, output is what? Output is g, the function g. So g of s0 and x0. That will give us our y0. And the next state is s1, which is what is the function of which maps to the set s, which is f. So f of s0 and x0. Then our next current state becomes s1, and my current input becomes x1. So then my next output symbol will be g of s1 and x1, and my next state will be s2, which is f of s1 and x1. And you can see that I can proceed, so and so on. Okay, now we can proceed in the similar fashion, and we can find all our symbols like this. Okay, so we can therefore extend the definition of the output function g to incorporate strings. Now we can just say that if we have this string of symbols, I can get this string of symbols. So I can just say g of x, and I'll just underline here, which means that it's a set of symbols or string of symbols. This is my y, and y is also a string of symbols, okay, or sequence of symbols. Okay, now let's do that. If we have an input string, this guy, so we have 0, 1, 1, 1, 0. This is my input. Now I want to find the output. Okay. Now my output is what? My starting state is what? S0. So I am at S0. So I'll write S0 here, and then I get a 0 input. So I'm at S0. I get a 0 input, and my output is what? 1. So my output is 1. And where should I go to? So what is my next state? My next state is again S0. Okay. Now my current state is S0 and my input is 1. So where should I go? I should go to S4, and my output is again 1. Okay. Now I am at S4 and my input is 1. So my input, so now again I go to S0 and my output is 0. S0, output is 0. Now my input is 1 and I am at S0. So I go to S4 again. So S4, and I go to, and my output is what? 1. Okay. Now I am at S4 and I get a 0, so I get to S1 and my output is 1, right? So this is my output for this string. So you can imagine any 5-bit string or any n-bit string, and you can find a function, you can find corresponding output for this state machine. And hope it was easy to understand, and thanks for watching. Hope you liked the video.